Open the NetSim and select Programming, the sliding window protocol. Select the sample mode and go back in Algorithm. Now select a data file which is stored in COMNET, data.txt being our data file. Now run the file. Uh, we see that data frame 1 is flowing from node 1 to node 2 with no error. Now I'm increasing the speed a bit, and similar is the case with data frame 2, which is flowing with no error. And it's the same case with the data frame 3. Now we see that data frame 4 is flowing from node 1 to node 2 with error. Now the size of the window depends on the protocol designer, and here we have window size being 7. The source node retransmits all packets of window from the first error node. In the code that we used, acknowledgement loss is not considered in the network. Each packet in the buffer has a sequence number starting from 1 and increasing up to the window size, that is being 7. Now acknowledgement is sent after one window frame is transmitted, that is 7 packets. This concept of repeating the transmission from the first error packet in the window is called go back N.
This is the code for go back N. So there are a few predefined functions in this code. The first one is fn go back N read input. It reads the input from the input.txt file. So the input.txt file has 5 lines in it. The first line, it names the algorithm, which is not important to us, so it skips that line. Here it's skipping the first line, and then the second line, it contains the file path to the data.txt, meaning the data file. So it is stored in input file path, and then the next line contains the error rate, which is stored in error rate, and then the fourth line, it is the sequence number, which is again not important to us, so it's skipped. And the last line contains the window size. And then the next function is the main function. It takes the input file path and error rate and window size as inputs, and it's the code for the go back N protocol. These are the variables used in this code. The total packets, this is the error flag, the len contains the file size, and then these are other variables. So the first scstr, it contains the input, the data file, the file path for the data file, so it is opened in read mode, and then these 3 lines, they calculate the size of the file. The size of the file is stored in the variable length, and then the variable is divided by 1500, which is the packet size, to calculate the number of packets. And then the error flag is initialized to 0. Number of packets are initialized to 0. The output file is opened in write mode, and then this is the main algorithm. The uh, while loop repeats itself each time a window is sent, and then an error window is a boolean which tells whether the previous window sent had an error or not. So for the first window, obviously it's not going to have an error, so it is 0. So when the error is 0, this part of the code is executed. So for each window, it takes each packet. This function, decide error function, it decides whether the packet has an error or not. It's a predefined function in the interface code, so it is used to decide the error. And then if there's an error in it, if there is no error in the function returns 0. So if there's no error, the packet is sent, error flag is set to 0. If there is an error, then the error flag is set to 1. And then after the packets have been sent, this part calculates the errors, and it sets the error packet to the first packet which had an error in it. If there are no errors, the an error window variable is set to 0, and then the start of the window is also updated. Else, meaning if there is an error in the previous window, again the entire window, this time the window starts from the error packet and the entire window is sent. Each packet, the error is decided, If there's no error, the flag is set to 0. If there is an error, again flag is set to 1. And again the number of error packets are counted over here. And finally the acknowledgement is printed after the entire window has been sent. So that is the code for go back in.
Now select the user mode and the executable file and data.txt as our data file and run it. We again see that data frame 4 is with an error, just like what we have seen earlier with the sample mode. The executable file has been created using code blocks and it's named in the name of gobackn in the debug folder. Now in the output section we can see that the data count, acknowledgement and total number of data frames sent is same as earlier. This is the input text file that we used. Just like in GoBackIn, now select selective repeat algorithm and select the data.txt file and run. Now we see that data frame 1 is flowing without any error from node 1 to node 2. And same is the case with 2 and 3. But 4 is now flowing with an error. And since the window size is 4, acknowledgement is sent after every 4 packets. The source code transmits packets continuously till the window size is exhausted. If any of the packets are received with error, only those packets are requested for retransmission. If all the packets transmitted are errorless, the next transmission is carried out for the new window. Concept of repeating the transmission for error packets is selective repeat.
This is the source code. This is the code for selective repeat in the sliding window protocol. These are all the predefined variables which contain the. So again, first the input is read from input.txt file in the temporary folder. It has 5 lines. The first line, it is the name of the algorithm. It is skipped. And the second line contains the file path to the data file. Then the third line contains the error rate. The fourth line is a sequence number, which is skipped again. And the last line contains the window size. So all these are read and then stored in local variables. And then next, the main function is called selective repeat function. The data file path, error rate and window size are passed into this function. These are the variables which are used in this function: the error flag, number of packets, packet sent, and error packet and window size. First, the data file is opened in read mode and the file size is calculated using fc_capital. The size is stored in length and then the size is divided by 1500 to calculate the number of packets. Then the output.txt file is opened here. This is where we're gonna write our output from the code. The while loop will repeat itself each time a new window is sent. So when a new window is sent, first the n error window boolean is checked. It tells whether there was an error in the previous window or not. So if there was no error, each packet in the window it'll start to send each packet in the window. For each packet, it will decide the error. If there is no error, the error flag is set to 0. If there is an error, the error flag is set to 1. And then after all the packets have been sent, the number of errors are counted. If there are no errors, the error window is set to 0. Otherwise, if there is an error, the error window is set to 1. And then the error packet is set to the first the first packet which has an error in it. And then the start of the window is also updated here. And then next, if there is an error in the previous window, so the window will start at the first error packet, and then it will send that packet, it will decide the error and then send the packet. If the packet has already been sent, meaning if error flag is 0, it means the packet has been sent without any error, so it is going to skip that packet, which is selective repeat protocol. So it will continue this for the entire window, and all the packets will be sent, and all the packets which have already been sent without error, they will be skipped. Again, for this time again, the number of error packets will be counted, and the error packet variable is set to the first packet which has an error in it, and that is the completion of selective repeat.
By selecting the user move, we get to run our own code, and since the code is written on selective repeat algorithm, choose algorithm as selective repeat, and the data file has been selected as data.txt, and now run the program. Now we see the same results as obtained earlier while using sample mode. They are exactly the same. So this output text file on the left of the screen shows us the output of the user code, and the file on the right side of the screen, which is named as temp.txt, is the output which is obtained from the sample code. So when we compare these outputs, we see that they are exactly the same. So